You click a button, something happens, or at least you hope something happens. Another user somewhere clicks login. That single click travels across networks, it hits servers, wakes up databases, triggers logic, checks permissions, and then makes a long journey back to your screen. Most people never think about it. Developers live inside it. Now let me ask you this. You visit a website or let's say an e-commerce site, you click a button and nothing happens. You click again and again and again, still nothing. You start wondering, was it the internet, the backend, or did the server just decide to rest? So here's the question. What actually goes on between that click and the screen changing? Where does your request actually go? Who listens to it? And why does it sometimes comes back with a hungry 500, 404, or a 400 error? I mean, what do this even mean? So today, we are breaking down what really happens between request and response from click to code. By the end of this episode, you won't just hear these terms, you would actually understand them. You will know what a request really contains, why get and post exist in the first place, what HTTP is all about without cramming the definitions, and how all of these show up in real apps and APIs you use every day. Welcome to Inside the Stack. I'm your host, Oluwale Majiagwe. And whether you're a beginner, a designer, or a developer, this episode will help you finally understand what's going on behind the scene. Let's discuss the big picture, request and response. Now, before we talk about headers, before we talk about methods, or before we talk about APIs, we need to zoom all the way out. Because at its core, the internet is just computers talking to other computers. That's just it. There's no magic. There's no cloud floating in the sky. There's no computer system anywhere in the sky. It's just machines sending messages back and forth. Machines sending messages from one to the other. So on one side, you have the client, and most of the time that's your browser, that's your phone, or even an app. While on the other side, you have the server. That's another computer somewhere else that is waiting for requests. You don't need any fancy terms to understand this. One side asks, the other side answers. That's the entire idea behind request and response. A request is simply asking for something. Give me this page. Save this form. Log me in. While a response is the answer. A response says, here's the page. Your data has been saved. Sorry, you are not allowed. Let's make this real. Let me use a restaurant as an example. When you get into a restaurant, you don't just walk into a kitchen and food magically appears before you. You sit down, you look at the menu, then you place an order. In the internet sense, that order is the request. The kitchen doesn't cook anything until you ask. And when they are done, the food comes back to you. That's the response. No order, no food. Now, here's another way to think about it. Imagine a librarian. If you walk into a library and say, hey, I want to read something, idea, nothing will happen. Nothing happens. But if you say, hey, I'm looking for this specific book now, that's a request. The librarian checks, finds the book, and hands it to you. That handoff is the response. And here's the important distinction. Sometimes you're just asking to read something. Other times you are submitting something. You are borrowing a book. You are returning a book. You are filling a form. different kinds of requests, but still the same idea. Ask, then answer. Now, this brings us to the most important takeaway in this episode. Nothing, I repeat, nothing, absolutely nothing happens on the web without a request. Loading a page is a request. Even seeing an image is a request. If nothing is asking, nothing is responding. Once you understand this, everything else we are going to talk about starts to make sense. Okay, so now that we understand the big picture, let's zoom in. Let's take a closer look. Because when a request leaves your browser, it's not just vibes. It's a structured message. Every request is made up of a few key parts. And once you understand them, a lot of things suddenly stop feeling mysterious. You understand them. So in this episode, we'll be breaking requests into 4 simple pieces: the method, the URL or the path, the headers, and the body. Now, let's take them one after the other. So, method. What action are you performing? Method answers one question. What do you want to do? Are you trying to get something? Are you trying to send something? Are you trying to change something? For example, when you visit a website, your browser is basically saying, hey, I want to get this page. Now, that's a GET request. Get as in G-E-T, to get something. But when you log in, you're not just asking to see something. You're submitting information now. You're submitting your email, you're submitting your password. Now, that's usually a post request. Same internet, different intention. The method tells the server what kind of action you want to perform. Now let's move on. The URL, or more specifically, the path. What does it do? The URL or the path also answers another simple question. What is this question? Where is this request going? Let me give an illustration. Let's think of the server as a building. The URL is the address, while the path is the specific room you are knocking on. In your browser, for example, you go to www.mysite.com. Now, that's the home page. You are getting the home page. When you click on the contact, in your address bar in the browser, you will see it change to maybe www.mysite.com/contact if you're going to the contact page, or www.mysite/about if you're going to the about page. Now, the / then the page, that is the new path, the room you are currently in. When you visit the home page, you're knocking on the door. When you submit a login form, you're knocking on a different one. Same building, different destinations. Now, if the path doesn't exist, or maybe you knock on the wrong door, you get a response like, hey, I don't know what you're looking for. That's where errors like 404 come from. Sometimes you might just not have permissions to enter or visit that room. For example, if you are not an administrator, when we get to some offices or when we get to some buildings, you would see staff only, security personnel only. That means if you are not a member of staff, you are not a security personnel, you are not allowed to enter those rooms. It's the same thing also for websites. Errors like 403 permissions issue, that is where it comes from. Now the next stop is headers. Now let's talk about headers. Headers are not the main message. They are the extra content. They answer questions like, who is making this request? What kind of data is being sent? What format should the response be in? Think of headers like notes attached to a package. They are not the package, but they give extra information that helps whoever is handling the package to know what to do. Information like, this is fragile, handle with care, deliver in English, not French. When you are logged into an app, your browser quietly sends headers to the server that says, hey, it's still me. Now, mind you never see this, but the server actually relies heavily on it. Now, finally, the body. The body is the actual data that has been sent. Now, mind you, not every request has one. If you're just visiting a page, there's usually no body. But when you perform actions like submitting a form, the body is where your data lives. Your login details, your sign up information, your checkout form. The body is the payload, the thing you're actually delivering to the server. So let's combine everything together. When you log into an app, your browser sends a request that says, hey, I want to post to this specific URL. Here is some extra information in the headers, and here's the actual data in the body. That's it. Not magic, just structure. Now, here is something important. Browsers hide almost all of this from users. You click, stuff happens. You don't bother about what's happening behind the scenes. But as developers, we can't afford to think like that. If you're building apps, building APIs, or anything on the web, you need to understand what's inside a request. Because when things break, this is where you debug. Now, let's talk about one of the more confusing topics on the internet. One of the things that confuses people, it's this get and post. The get and the post method. They sound technical, they sound scary, but the idea behind them is actually very simple. So come along. Let's break it down. Now, what is get used for? Get is used to fetch data. Get is for reading. You're asking the server to give you something, whatever it is, maybe a page. You're asking it to give you a list. You're asking it to give you an image, some data. You are just getting it. Now, here's the important part. Get does not change anything on the server. With get, if you're making any get request, you are not supposed to make any changes on the server. You're just looking. You're not touching. When you open a website, that's a get request. When you search for something, that's usually a get request. When an app loads a list of items, that's also a get request. Well, you often see get request in the URL. Remember what I mentioned about URLs and paths being buildings and rooms? Well, you would see the get request in the URL, the paths, you will see the search terms, you will see the filters, you will see the page numbers, all of that can show up right there in the address bar on your browser. Now to posts. Post is different. It is for sending data to the server. You are not just asking to see something, you are asking the server to do something, to create something, to update something, to change something, to delete something. When you log into an app, that's a post request. Now, I mentioned to update, I mentioned to change. There are actually other bodies or other requests that you use, but for the purpose of this, we would be using posts. I'll be talking about posts. So when you sign up, that's a post request. When you log in, that's a post request. When you submit a form, that's a post request. And unlike get, the data is not usually visible in the URL. It lives inside the request body. So why does this distinction matter? Why does this matter? You need to know that this isn't just convention. Servers treat get and post differently. I mentioned earlier that there is delete, there is put, but we'll just be talking about the get and the post method for this episode. Servers treat get and post differently. Browsers treat them differently. Security tools treat them differently. Caching systems treat them differently also. So knowing what to use and choosing the right one matters a lot as a developer. A simple analogy here, think of get like reading a menu. You're free to look, nothing changes. Now, post is when you place an order. Something is about to happen. The kitchen starts working. State changes. If you remember nothing else from this episode, remember this, the golden rule. If you're reading, get. If you are sending or changing, post. That one rule will carry you very far. Also remember, get is safe to look. Post is meant to act. Once you understand intent, the confusion disappears. Now that we understand how requests are made, let's talk about the language they speak. Hypertext Transfer Protocol, which is commonly known by its acronym HTTP. Now, HTTP. It sounds serious, it sounds technical. It sounds like something you're supposed to memorize. But HTTP is actually very simple. HTTP is just a rulebook, that's it. A shared agreement on how computers actually talk to each other on the web. HTTP doesn't tell the computers what to say. It tells them how to say it. It defines how the request should look, how responses should look, and how errors are being communicated. So when your browser sends a request and the server receives it, both sides already know the format. No guessing, no assumptions, just structure. It's like speaking, it's like talking, Request and response, they speak HTTP the same way you and I speak English. If I was to speak English and you speak Chinese, we would not understand each other. Now, HTTP is the reason your browser and your server can understand each other at all. Now, here's one of the most important ideas in HTTP. HTTP is stateless. Now, what do I mean when I say stateless? It means every request stands alone. It does not save states. It does not save the previous one. The server does not automatically remember you, does not remember the last request that came in. Each request comes in, it gets handled, and is forgotten. If the server knows who you are, it's because your request included that information. Now, how does this happen? It happens in your cookies, maybe in your tokens or your headers. It does not use memory. Now, this is why authentication exists and why headers matter so much. Now, let's talk about one more thing. HTTP versus HTTPS. You might be thinking, HTTPS. Which one is HTTPS again? HTTPS is still HTTP, but with an extra S, which stands for secure. That's just it. Hypertext Transfer Protocol, secure. Now, HTTP means the conversation is encrypted. Your data is scrambled while it is traveling, so no one can read it in transit. Things like your passwords, like your tokens, personal informations are all protected. Now, without HTTPS, anyone on the network can listen in. They can listen in. That's why HTTPS is not optional today. Modern browsers expect it. Users expect it. Security depends on it. Now that we understand requests, we understand methods and HTTP, let's look at how things fail and what those error codes actually mean. As a user on the internet, you would have definitely seen an error code, maybe a 404, 500, or a 403. They look cryptic, but they're actually the server trying to communicate with you. They're actually the server trying to tell you something. You need to understand that error codes are messages, not insults or something meant to confuse you. An error code is not the server being rude. It's the server explaining what went wrong using the rules of HTTP. Remember, every language has their own rules. Error codes is also one of the rules of HTTP. Every response from the server comes back with a status code, even the successful ones. The difference is we only notice them when something breaks. So now let's talk about them. Instead of memorizing numbers, let's talk about them in categories. Think in categories. The major categories we have are the 200s, we have the 400s, and we have the 500s. Now, these are the error codes I'll be talking about. I'll start with the 200s. The 200s status code simply means everything worked. Like, they mean success. The request was understood. So whether it's 200, whether it's 201, whether it's 202, 204, 205, 230, whatever it is, as long as it starts from 200 and something, that means that the request was understood. As long as it starts from 2, the request was understood. The server did what you asked. Now, you don't usually see this because, success feels normal. There's nothing to change when success happens. Now, 400. The 400 categories means something has happened. The request was the problem. It means something about the request was wrong. The server understood you, but it couldn't proceed due to your request. That just means change your request. 404 means, hey, you requested for a resource, but I can't find it. 404 means not found. Like that is just what it means. Now 403 means I know what you want, but you are not allowed. You are not the staff. You don't have the correct permissions. 400 means, hey, this request doesn't make sense. In short, the request needs fixing. I don't know what you mean. So let's translate this into real life. You walk into a restaurant, you order something not on the menu. That's a 404. The restaurant does not know what you are ordering. So that's 404, not found. If you try to order from the kitchen without permission, that's a 403. If you place a valid order and the kitchen catches fire, that's 500. 500 are server errors. Same rules, different environments. Now, why does this matter? Why do we need to understand the status code? It's simply because understanding error codes, they help you debug faster. It tells you where to look. Now, I said 400 means there's something wrong with the request. So when you say 400 error, hey, check the request. There's something about the way I'm doing, the way I'm making the request. 500 means check the server. No guessing, no public. With 500, you just need to check the server. There's something wrong. Now, before we wrap up, now mind you, you don't need to master them today. This is just awareness. A very important one is TCP, which stands for Transmission Control Protocol. Now, you should know that underneath HTTP is TCP. I need you to cap that. You need to clock it. TCP is all about reliability. It breaks messages into smaller pieces or packets. It makes sure they arrive in the order that they're supposed to arrive, and it retries anything once it gets lost. Here's a simple way to remember it. TCP makes sure the message arrives. HTTP decides what the message says. Another protocol you will hear about is WebSockets. As we've discussed so far, HTTP works as request and response. Ask, answer, done. WebSockets work a little bit differently. They keep a connection open so data can flow both ways in real time. That's what powers things like a live chat, real-time real-time dashboards, and streaming metrics, as they need real-time or live updates. Now, we have protocols for sending emails and for sending files or uploading files. Email and file protocols, they handle how emails and files have been sent. Popular email protocols are the SMTP, Simple Mail Transfer Protocol, and the IMAP. So for files, we have our trusty FTP, File Transfer Protocol. These protocols, they have their own specific use cases, and there's a way you structure your request around them. So you need to remember the internet runs on multiple protocols. It runs on multiple rules. So now you need to remember the internet runs on multiple protocols, each handling a specific responsibility. You don't need to learn them all at once. You just need to know that they exist. Now let's gently connect all of these to the apps you use every day, whether it's a website, whether it's a mobile app, or an internal dashboard. They all work the same way underneath. Every tap, every click, every refresh, they turn into a request. And every screen update is a response coming back. Some systems organize this request using patterns you will hear about later, like REST of GraphQL. But you don't need to know the details yet. What matters is this. They all use HTTP. They all still send requests, and they all still receive responses. Even GraphQL didn't replace HTTP. It just simply uses it smarter by being more precise about what data is requested and what gets changed. Mobile apps do this constantly in the background. Web apps do the same thing through your browser. Dashboards refresh charts and numbers by sending more and more requests. The interface looks different, but the conversation underneath is exactly the same. Once you see apps this way, they stop feeling like black boxes. They are just systems having structured conversations. Requests going out, responses coming back over and over and over again. Let's quickly talk about a few common mistakes beginners make. Now, I'm not trying to call anybody out, but we've all done this. One of the most common mistakes is using get for login. You need to know that logging in is not just reading data. You are sending credentials. You are changing states. That should never be a get request. Login should always be a post. Now, another mistake we make is sending sensitive data in the URLs. The URLs get logged. They get saved in browser history. They get shared accidentally. Passwords, database keys. Yes. I'm talking about you using your auto-incrementing IDs in your URLs, tokens, and so on. These are private informations, and they should never live in a URL. You need to understand that URLs get logged, they get cached, they get shared. If it is sensitive, please know it doesn't belong out there. Because once you get this, everything else starts to make sense. Every interaction on the web follows the same flow. The client asks, the server decides, the server responds, and the client reacts. When you click a button, the client is asking a question. When the server checks permission, runs logics, or talks to a database, the server is deciding. When data or an error comes back, that is the response. And when the screen updates, the client reacts. Get and post are just different kinds of question. HTTP is the rule book that keeps the conversation clear. Error codes are the servers explaining what happened. Once you see apps this way, you stop guessing when something breaks. You know where to look. And this is the real shift. This is the real shift. Once you understand requests and responses, the web stops feeling magical and starts feeling predictable. Now, today, we didn't learn frameworks, we didn't memorize acronyms, we learned how the web actually works. From the moment you click to the request that's sent to the response that comes back. Understanding the web isn't about being smart. It's about having the right mental model. Once you understand requests and responses, you stop guessing and you start building with confidence. Now, that's the shift. The web stops feeling magical and starts feeling predictable. If this episode helped you see things more clearly, share it with a friend, a designer, or a developer who is just figuring things out. Subscribe to Inside the Stack for more episodes where we break the stack down, layer by layer, until it finally makes sense. I'm your host, Oluwole Majirabe, and I'll see you in the next one. Bye.